Okay students, welcome back. So today we will see some simple concepts: electric field, its expression, then what do you mean by electric field lines, flux and dipole and its moment. Now suppose there is a point charge over here plus Q. At point O there is a charge plus Q. Then another charge of one coulomb is placed at a certain distance, unit positive charge. Then the force experienced by this unit positive charge is called electric field. So electric field is defined as a force experienced per unit positive charge placed at a point. So you can say E is equal to F by Q. E is equal to F by Q. So from this you can write its SI unit easily. So if I take SI unit, so force it is measured in Newton, charge in coulomb, so Newton per coulomb, SI unit of this. Electric field, it is a vector quantity. It is a vector quantity, means it has a direction. So how we take direction is, electric field is taken away from positive charge. Suppose there is a positive charge like this, so there is a plus Q. Then electric field due to this charge is taken away from it. So in this form or in this direction E is taken. If it is a negative charge, then direction of electric field is taken towards negative charge. It is taken towards negative charge. So electric field means, just you can remember this formula, force per unit positive charge. SI unit is Newton per coulomb. Now we will see expression for electric field, means we will see formula which he will be asking for 2 marks. So first I will take same a point O at which a charge plus Q is placed, that is a point charge. So P is a point at a distance R from O where electric field is to be determined. This distance I will take it as R. So here I have taken positive charge, means electric field is directed away from positive charge. So here I will take direction. So direction E, away from positive. So here this charge, point charge at O which we have taken, that is called source charge. Source charge. So I am required to find electric field at point P. So imagine there is a unit positive charge, or you can take, so here there is a unit positive charge, that we call it as a test charge. Test charge. While solving problems and all, he will not be giving this charge. We imagine or take there is a one coulomb. So now we are required to find formula for E. Now if I take by definition, so by definition electric field is equal to, just now I have told definition is force experienced per unit charge. So E is equal to force experienced by unit positive charge. So one coulomb charge. So now apply Coulomb's law formula over here. Force experienced by one coulomb charge. So if I apply Coulomb's law between these two, I will have 1 by 4 pi epsilon naught Q into 1 divided by R square. Divided by R square. So you will have E is equal to 1 by 4 pi epsilon naught Q divided by R square. This is expression for electric field. So on this formula again we will be having problems same as that on Coulomb's law. Sometimes for 1 marks he may ask vector form of electric field. So if you take vector form, vector form. So E arrow mark. Again on the RHS vector is R, or we say position vector. So 1 by 4 pi epsilon naught Q divided by R square into R cap. Q divided by R square into R cap. So 1 marks he will be asking this. So this is about electric field. So next we will see what do you mean by electric field lines. So now I will take a positive point charge, or a positive point charge and a negative point charge I will be taking. In between these two, anywhere, if I place a 1 coulomb charge, here I am placing 1 coulomb charge. So that 1 coulomb charge will not remain steady over here. This will be repelled by the positive charge and will be attracted by the negative charge. So this gets repelled from this and it moves towards negative charge. So the path traced by unit positive charge or 1 coulomb charge when placed in an electric field, that path we call it as electric field lines. So it starts from positive and ends at negative. So these are called electric field lines. Or in other way, you can define in this form also. So on a line, just I will take this line. If you take any point or point anywhere on the line and draw a tangent at that point. So I will take a point, I will draw a tangent over here. So that tangent gives direction of resultant electric field at this point. So if I take point over here, you draw a tangent. So at this point electric field is directed in this direction. So even electric field line is defined in this way also. These are imaginary lines joining the charges. At any point on that line, if you draw a tangent, it gives a direction of resultant electric field. So it is a point on the curve or on the line. At any point on it gives a direction of resultant electric field. So now, if I take its properties. So first properties, just now I told, it starts from positive and ends at negative. So it starts from positive charge and ends at negative charge. So lines are shown in this form. So it starts from positive and ends at negative. Second, suppose there are isolated point charges. Isolated means only positive or only negative. So if I take a positive, isolated means only one. It starts from positive and ends at infinity. It starts from positive and ends at infinity. If it is negative, it starts at infinity and ends at negative charge. If it is a negative charge. So second point is electric field lines starts or ends at infinity for isolated point charges. Third one, electric field lines does not form a loop. You will never get lines in this form. So like this, it doesn't form loops. This is not possible. Just you may think, or if one column is placed here, it will go to the negative charge by the shortest path. It will not move in a curve, so it does not form closed loops. Fourth, this is important. No two lines of forces intersect. You will never have lines in this form. No two lines of forces intersect. Why they don't intersect? Now if I take this point of intersection as point P. At point P, if you observe, you can draw two tangents, one to this first curve and another one to this second curve. So you will be having two tangents. Means at this point there are two directions for electric field, but resultant electric field will be always having a unique direction or only one direction. So it will never have two directions. Therefore, two lines of forces will never intersect. Two lines of forces will never intersect. This is important. Fifth, electric field lines. Same definition what I have told. Tangent at any point on the curve gives direction of electric field. Tangents at any point on the curve gives direction of electric field. Sixth, so electric field lines starts from the surface of a conductor. It will not pass through a conductor. Suppose this is a charged sphere. It is having a positive charge Q I will take. So electric field lines will start from the surface and ends at the surface. You will never have in this form. This is not possible. This is not possible. It starts from the surface and ends at the surface. Seventh one, electric field line is always normal to the surface. Normal means perpendicular. So here, if you draw tangent, this line and tangent will be perpendicular to each other. So it is always normal to the surface. And lastly, if electric field lines are very near to each other. So they are very close to each other. Suppose this is positive charge. So if I show electric field lines, they are very near to each other. Then it indicates that there the electric field is strong. If lines are near to each other, electric field is strong. And suppose if field lines are far like this, this indicates electric field lines are weaker. Here electric field is weak or field is not so strong. So these are properties. From exam point of view, you remember any 2 or 3 properties because he will be asking it in 2 marks. So first, electric field line means at any point on the line, if you draw a tangent, it gives a direction of resultant electric field. Properties: starts from positive, ends at negative. If it is isolated charge, starts or ends at infinity. It doesn't form closed loop. No two lines of forces intersect. Why? Because at intersection you will be getting two directions of electric field, which is not possible. This is same as the definition. It starts from surface, ends at surface. Always it is normal to the surface. And if lines are very near to each other, field is stronger. If they are far, then field is weaker. This is about electric field lines. So if you want, you can pause and note down, then we'll go for the next concept. Okay. Next we'll see what is electric flux. So just now I told field lines will start from positive and ends at negative. Now here I will take a positive charge. A positive charge is there. So electric field lines will be starting from this positive charge. So field lines are there starting from this positive charge in all the directions. Now imagine you are placing a area or a certain surface normal to this electric field line. You are placing a surface normal to this electric field line. You may think that these lines are passing through this surface. Or just imagine there is a charge. You are holding your notebook perpendicular to this, that is perpendicular to the board. Now, the number of lines which strike that notebook or pass through that notebook, the total lines which are passing through that notebook. If you count all those lines, that together we call it as electric flux and is denoted by phi. So total number of lines passing through a surface held normal to these lines, that total number of lines if you count, that we call it as electric flux. Now these lines are not real but imaginary. It's not real. So for example, during school days you might have drawn scenery drawings like this. Hill is there, then you will be showing sun, you will be showing rays like this. These are not real, just it depicts that sun is there or he is shining. Similarly, here also these lines are not real, they are imaginary. So if they are imaginary, you cannot count the number of lines. So this definition is just a theoretical definition. That is the number of lines we are telling. But for some derivations, we use a mathematical definition of flux. Now suppose resultant electric field due to a number of charges, it is in this direction I will take. This is resultant electric field E. Resultant electric field. Then I will take a surface normal or in this direction. Just here I told notebook. Similarly, area, surface area, and its area I will take it as dA. Now I will draw normal to this surface area over here. I will draw a normal. Let this angle be theta. This angle be theta. Now I can resolve this E along the direction of normal from the first year resolution of vectors. If I resolve this, so I will be having E cos theta along the normal to this surface. So mathematical definition of flux is, it is a product of E cos theta and dA. So mathematical definition is product of normal component of E and cross sectional area. So just you remember formula, definition you will not be asking. So phi is equal to E cos theta into dA. Even from this you can write SI unit of flux. Just by formula you can remember E Newton per coulomb, cos theta it is unitless, dA is meter square. So SI unit will be Newton meter square per coulomb. Newton meter square per coulomb. So definition, just theoretical definition is total number of lines passing. Mathematical definition is E cos theta into dA. This formula is important for derivations. So lastly, what do you mean by a dipole and dipole moment? So dipole means 2 point charges equal in magnitude but opposite in sign, that is unlike charges. So 2 point charges, one I will take it as minus q and second one I will take it as plus q, separated by a very small distance, 2a. This together we call it as electric dipole. So electric dipole means 2 unlike equal charges separated by a very small distance is called dipole. The line joining these two charges, is called dipole axis, and its direction is always taken from negative to positive. So dipole moment means, it is denoted by P. Dipole moment is denoted by P. It is a product of either of charge and distance between those two charges. It is product of either of charge Q into 2A, or we write it as P is equal to 2A into Q. This is formula for dipole moment. Product of either of charge and distance between those two charges. So again from this formula you can write SI unit of P. You can write SI unit of dipole moment. So charge into distance. Charge coulomb, distance is measured in meter. So coulomb meter is the SI unit. Dipole moment is also a vector quantity and its direction is taken along dipole axis. Its direction is taken from negative to positive. So if you write vector form, so you will have P arrow mark Q into 2A. This is vector form of dipole moment. So these are few concepts which are just easy. So in the next video we will be seeing some problems on electric field and important derivations on dipole and electric field. Okay, thank you students.